Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE October-November 2019 paper 41 for IGCSE math. It's a 2.5-hour test. So again, we're going to go over the worked solutions and make sure that you pay attention on how to set up the problems. Also how to solve the problems and make sure that you can think through the steps yourself. So let's get started here. First question is an angle question. We need to find the values of P and Q. So here you see a 48 that's given. And this angle right here and this angle right here are called vertical angles. Vertical angles are equal. And then AC is a straight line, means they're supplementary angle. They're supplementary or they add up to 180. So 180 minus the 48 gives us 132. That's the value of angle P. Then Q is in this triangle. We know a triangle adds up to 180. So 180 minus the 55 plus 48 gives us 77 degrees for Q. The angles of a quadrilateral are x plus 5, 2x minus 25, and x plus 10. Well, let's see how many angles should be in a quadrilateral. So we use the interior angle formula, which is n minus 2 times 180, where n is the number of sides. It's a quadrilateral, so there's 4 sides. 4 minus 2 is 2 times 180 is 360. So 360 is the total number of interior angles. So x plus 5 plus 2x minus 25 plus x plus 10 should equal 360. Combine like terms, 5x minus 10 equals 360. Divide by 5, x equals 74 degrees. A regular polygon has 72 sides. Find the size of an interior angle or one angle. So again, we have 72 sides. So 72 minus 2 is 70 times 180 is a total of 12,600 degrees of interior angles divided by 72 because there's 72 angles. And that gives us one interior angle has 175 degrees. Moving on to this diagram. Now there's a lot of stuff already written here, so you might want to look at it without all of this stuff written on it. Notice that AC is a diameter, PQ is a tangent, and they give us this 60-degree angle and this 20-degree angle, and they want us to find U, V, W, X, and Y. So let's start here with U. If you notice, AC is a diameter, and when you have a radius coming from the center and meeting a tangent line at the point of tangency, then that means the tangent line is perpendicular or 90 degrees to your radius or your diameter. So if this is 90, 90 minus 60 gives us 30. So that's our U is 30 degrees. Now also notice that AO is a radius and OD is a radius. So these two sides are the same, meaning these two angles are the same. So this is 30 and this one over here is 30. And this is a triangle, so it adds up to 180. So 2 times 30 is 60. That's this one plus this one over here. And then 180 minus the 60 gives us 120, which is our value of x. And notice I put it on the central angle. I also put it out here on the arc. Central angles are equal to the arc. And I do that because sometimes the middle of the circle gets kind of crowded, so putting it out here kind of helps to see things. Now if we look at V, V is an inscribed angle that opens to this arc. So notice right here, here's the edge of the arc here, inscribed angle V coming out to this side of the arc here. So an inscribed angle is half of the arc that it opens up to. So half of 120 is 60. So that's letter V. Then if we notice W also opens up to the same arc. It's also an inscribed angle and it opens up to the exact same place that V does. So V equals W, therefore W is also 60 degrees. Now Y is a little bit more tricky here. We already have the 60 for W and we have this 20 over here. So 180 minus the 60 and 20 gives us 100 left for this corner. And then this is a straight line. So 180 minus 100 gives us 80 for right here. Also over here we have the x, which is 120. This is a straight line, meaning it adds up to 180. 180 minus 120 is 60. So now we have the 80 and the 60. And we take 180 minus the 60 and the 80, and that gives us 40 degrees for the y value. So there's our u, v, w, x, and y. I didn't solve them in that order, but just kind of according to as I worked through it. Then E, you have this ABC lies on the circle with center O. AOC is this 3x plus 22, and ABC is 5x. Find the value of x. Well, notice that 5x is an inscribed angle. So it's going to be half of this arc that it opens up to. So here we have 5x equals half. Now we need to figure out how to get this arc that it opens up to. Well, remember the arc is the same as the central angle. And this central angle is part of a complete circle here. So 360 degrees minus the 3x plus 22 will give you this arc. So 360, the whole circle, minus the 3x plus 22 gives you this central angle, which is this outer arc, and that is going to be half of that will be the inscribed angle. So I multiplied the 2 to the other side, make it 10x equals 360, distribute your negative minus 3x minus 22, then add the 3x to the other side, 13x equals 338, then divide by 13, so x equals 26 degrees. Now you have Ali and Mo share a sum of money, and the ratio Ali to Mo is 9 to 7. Ali receives $600 more than Mo. Calculate how much each receives. So the ratio that we're given is Ali to Mo is 9 to 7. Mo is an unknown value, x, and then Ali receives 600 more than Mo, so x plus 600 for Ali. So Ali on top, Mo on the bottom, x plus 600 over x equals 9 over 7. Cross multiply, and you get 7x plus 4,200 equals 9x. Subtract 7x to both sides, 2x equals 4,200. So x, which again represents Mo, is 2,100. Ali is 600 more than that, so Ali is 2,700. In a sale, Ali buys a television for $195.80. The original price was $220. Calculate the percentage reduction on the original price. So the original minus the sale price over, because it's a percentage, over the original. So the original minus the 195.80, that's the reduction. And then the percentage means divide by the original, and you get 24.2 over 220, which reduces to 0.11. As a percent is 11%. In the sale, Mo buys a jacket for $63. The original price was reduced by 25%. So the original price is going to be represented by 1, which is 100%. Reduced or subtract 25% means that he got his sale of 75% of the original. So 75% of the original equals the sale price of 63. Divide by 0.75 means the original cost of the jacket was $84. Number 3, Dina invests $600 for 5 years at a rate of 2% per year. Compound interest. Calculate the value of this investment at the end of 5 years. So we're looking for the amount after time. So the original amount was 600, and this is your compound interest formula. You start with 1 being 100% of the original amount. plus you're going to increase at 2% per year. So that's 0.02. And then you put time up here, which is for 5 years. Calculate all this on your calculator. Your amount after the time is $662.45. Since it's dealing with money, you go to the cents place, 2 decimal places. The value of a gold ring increases exponentially. Again, exponential formula is same as compound interest at a rate of 5% per year. The value is now $882. So this $882 is the final value, and we want to calculate the ring 2 years ago, or its original value, or value 2 years ago. And so 1 represents the 100% amount at that time, plus it increased at 5%. So increase would be plus, and then 0.05 for 2 years. When you calculate this part right here in the parenthesis and exponent, you get 1.1025 times the original amount. Just divide that over into your 882, and you find out that the original amount was $800. Find the number of complete years it takes for the ring's value of 882 to increase to a value greater than 1,100. So here we have our 882 with our same interest, 1 plus 0.05. Now we're solving for how many years it takes for this value to be greater than 1,100. So we divide by our 882, put it over here. You can make it a decimal if you want, or just leave it as a fraction. The 1 plus 0.05 is 1.05. That's in the parentheses, so that can be done separately. Now, at this point, we have an exponential. I don't really like this about Cambridge because this particular question type actually involves logarithms, and you haven't been taught logarithms yet. And I guess they expect you to trial and error figure it out, but that's not really good math unless you don't understand what to do. So an exponential, to get rid of the base of an exponential, you log both sides with the same base. So basically what you can do as an IGCSE student who hasn't had logarithms, when you want to solve for this t, you find on your calculator the log button that has a little box right here and a big box right here. It's usually in the upper right-hand corner of your calculator. And so you look for that log button feature with the little box and big box. In the big box, you put the value that you had on the other side from your variable. And then in the little box, you put the base of your variable. So you have log 1.05 goes in the little box, and then this 1100 divided by 882, or if you had it as a decimal, you put that in the big box. And when you calculate that on your calculator, you should get 4.527. Notice it says find the number of complete years that it takes to exceed 1,100. So you round this up to 5 years. Calculate the external curved surface area of a cylinder with radius 8 and height 19. So if you can envision a cylinder with a circular top, the sides, and a circular bottom, this just wants the curved part. So you're not going to calculate the top or bottom, just the sides. So to get all the way around it, you have to do circumference, 2 pi r, where r is 8. And then multiply it by the height to get that curved area, and you end up with 955.04 or 955 to 3 significant figures. Part II, this surface is painted at a cost of 0.85 cents per square meter. Calculate the cost of painting this surface. So you have 955 square meters times 0.85 per square meter, and you get $811.79. Don't forget to round up the 8 to a 9. And this is money, so you go to 2 decimal places. This one was pretty easy, but it is a linked problem, meaning you're not going to get the second one right unless you got the first one right. So while the second one is easy, it is dependent on you getting this first part right. Part B, a solid metal sphere with radius 6 is melted down, and all of the metal is used to make a solid cone with radius 8 and a height of 6. Show that the height is 13.5. It gives you the volume of a sphere and the volume of a cone. Well, our metal starts in the shape of a sphere. So let's start with finding our volume of a sphere. 4/3 pi r cubed, where the radius is 6. So the total volume of metal is 904.7786842. And I just rounded it there to 2 decimal places. Then we're going to set that equal to the volume of the cone, because this volume is now turned into a cone shape, where we have 1/3 pi r squared, where our radius is now 8 and an unknown height. So when we calculate this 1/3 pi times 8 squared, we get 67.0206. Divide that into the total volume, and our height is indeed 13.5. Now calculate the slant height of the cone. So here's our cone. The height is 13.5. The radius was 8. So this creates a right triangle. The slant height is the hypotenuse. So do your Pythagorean theorem. L squared equals, by the way, slant height is usually designated by the letter L. I don't know why, but it is. So you have 8 squared plus 13.5 squared equals L squared. And you work that out, square root both sides, and you get a slant height of 15.7 to 3 significant figures. Calculate the curved surface area of the cone. So now the curved surface area is pi RL. It gives that, meaning we're not including the base, just the curved part, not the flat part on the bottom. So area is pi RL. The radius was 8. The L we got from right here. Again, it's a linked problem, so you have to have this 15.7. Notice I went back and used the 2 decimal places just to be a little bit more accurate. 15.69 times 8 times pi gives us 394.39 to 3 significant figures is 394. Letter C, the two cones are mathematically similar. The total surface area of the smaller cone is 80 centimeters squared. The total surface area of the larger cone is 180 centimeters squared. The volume of the smaller cone is 168 cubic centimeters. Calculate the volume of the larger cone. Well, we start with the ratio, because it says they're similar, of what we are given, and that is area. So we're given area. Small cone to large cone is 80 to 180. Notice it's in centimeters square. And we want to compare it in volume. Volume is cubed. So the first thing that we're going to do is we're going to reduce our ratio here to 4/9. Then to get rid of the square, we're going to square root it. And that takes us from area down to length, or 1 dimension instead of 2 dimensions. So our ratio for length is a 2:3 ratio. Then to get to volume, we will cube that, because now we're in centimeters instead of centimeters squared. So we take our centimeters and cube it. And so now our ratio becomes 8:27 for volume. So a 4:9 ratio of area is a 2:3 ratio in length, which is an 8:27 ratio in volume. So now we have 168 for the small cone over the large cone. We don't know. X has the ratio of 8:27. Cross multiply, 8x equals 4,536. So x equals 567 cubic centimeters. That's the volume of the large cone. Here we have a diagram with a pyramid with a square base. DB is 8. And so since it's a diagonal and the center comes down at a 90-degree there, it cuts the base in half. So that would put 4 and 4 for each of these little side parts. The height is px is 5, so that gives us a right triangle here. It wants us to calculate the angle between PB, here's PB, and the base. So between PB and the base is this angle right here, which is right inside of our right triangle here. So from our angle, we have the opposite and the adjacent. So we're going to use tangent. That's from our Sekolah. Tangent of the angle equals 5/4. Inverse tangent both sides to get the angle by itself. Make sure your calculator's in degree mode and you get 51.3 degrees. Now we get to this triangle and bearings problem. This triangle is not a right triangle. Diagram shows a triangle field ABC on horizontal ground, meaning it's flat. Olav runs from A to B at a constant speed of 4 meters per second, and then from B to C at a constant speed of 3 meters per second, and then he runs at a constant speed from C to A, and the average speed for the whole journey is 3.6 meters per second. Calculate his speed when he runs from C to A. Well, it gave us average speed. Average speed is total distance over total time. So the total distance is easy. It gives us 120, 180, and 150 as the three legs of this trip. So 120, 180, and 150, that part's easy. But now we need to calculate time. Well, time is distance divided by speed. Remember, rate times time equals distance. So if you solve for time, it's distance over rate. So 120 divided by 4 would be 30 seconds. And then 180 divided by 3 is 60 seconds. And then we're going to put an X here for the number of seconds that it takes to do this third section. And the total average speed is 3.6. So when we add that up, we get 450 over 90 plus X. Multiply the 90 plus X to the other side, and that gives us 450 equals 324 plus 3.6X. Subtract the 324, gives you 126 equals 3.6X. Divide by 3.6X, and X is 35 seconds, meaning it takes 35 seconds to run this third section, but the question is asking for the rate. So if time equals distance over rate, then rate equals distance over time. So 150 over 35 seconds is 4.2857, or in other words, 4.29 meters per second is how fast he traveled that last 150 meters. Now B says to find angle BAC. So here's angle BAC is this angle right in here, BAC. We want to find this angle. Notice we have a side here, 120, without a corresponding angle. We have this side without this angle that we're looking for, and we have this side over here without an angle over here yet. So we don't have a pair. We don't have a side with its corresponding angle, so we have to use the law of cosines. Notice it tells you to use the law of cosines, but you should be able to figure that out because you don't have a pair to work with. You don't have a side and an angle. I have the angle answer written there, but we haven't figured it out yet. So you do C squared. C is the side opposite the angle you're solving for. That's the 180. And then the A and B are the other two. So C squared equals A squared plus B squared minus 2AB, cosine of the angle. So notice the side here has to correspond with the angle here. And then these two are the other sides. So when you do all those squares out, you get these numbers. And you add these two together. Now be careful, you cannot subtract right here because this is a multiply and multiply has to come first. So we need to divide, we need to subtract 36,900 from 32,400. it actually comes out to be a negative 4,500, but then we're going to divide by the negative 36,000, and those two negatives cancel. So I didn't really show that. So when you subtract this over, you have to do that first. You can't subtract these two numbers because this is multiply. So you have to subtract this over here. It makes it negative, but then you divide to get rid of that multiply. You divide by the negative 36,000, and this negative with the negative that you got from subtracting, those two cancel out. And so you end up with then a positive. And then you inverse cosine both sides. Again, make sure your calculator's in degree mode, and you should get 82.8 degrees for angle C, and I put 82.8 there. Now it tells us that the bearing of C from A is 210. So C from A, meaning we're starting from A, and you always start with north and you go clockwise until you're facing C. So from north, from right here, going around clockwise, this total amount right here is 210. And we already know the 82.8 now. And this question says find the bearing of B from A. So we want to face B from A. So we start at A and we want to go clockwise until we're facing B. So that's this right here. We know this is 210 minus the 82.8 will give us the direction facing towards B, and that comes out to 127.2. Then it says find the bearing of A from B. So A from B means we start with B facing north. We need to come around all the way this way. So if we go back here, we know that this amount here was 127.2 minus the 90. We know that this north, south, east, west makes 90 degrees. So take out the 90, and that leaves you a 37.2. Parallel lines cut by a transversal, your alternate interior angles are equal. So this 37.2 is same as down here between this north and the west here. So that's 37.2, and we want to go from B, or we want to face A from B. So we start at north, we go around, there's 90, here's 180, here's 270, and then we need to add the 37.2. So 270 plus 37.2 is 307.2. D is a point on AC that is the nearest to B. So if you are on the line AC and you're closest to B, then that means this is going to be perpendicular. A perpendicular distance is the closest distance between a point and a line. So you just extend this line here, make it, appear to be perpendicular, and that's where your point D is. So we want to find out how far it is from D to A. So that's our unknown. We know the hypotenuse here is 120, and we already know the angle is 82.8. So notice from our angle, this is adjacent and hypotenuse. So we're going to use cosine. Cosine of 82.8 equals the adjacent over hypotenuse. Multiply the 120 to the other side. Calculate that out on your calculator, and your x is 15.0 to 3 significant figures. That is your distance from D to A. Moving on here, we have cumulative frequency diagram. There's shows information about times taken by 200 students to solve a problem. So the time in minutes all the way from basically 0 minutes all the way up to 1 hour of time, or 60 minutes. And it asks us to find the median. The median is halfway. So the median is the middle. The middle of 200 students would be 100. So we follow 100 over to our graph. It would be better if you use a straight edge on your graph paper, then turn perpendicular and follow it down. And we see that this is 34 minutes. is the median, the middle time. Now the interquartile range is Q3 minus Q1. While Q3 is 75%, 75% of 200 is 150. So we follow 150 over and down, and that's 43. Then 25% of 200 is 50. So we follow 50 over, which by the way, 50, these values are right in the middle of the square. So be careful of that. Make sure you pay attention to your scale here, both the 150 and the 50. I just drew it freehand, but it would be better if you used a straight edge to get it right there in the middle. Once you get over to your graph, turn 90 degrees and go straight down. So I have 43 to 25, and 43 minus 25 is 18 is the interquartile range. Now find the number of students who took more than 40 minutes. So now we're going the other way. We're going from minutes up. So we start with 40, and we're looking at the more than 40 minutes, which is this side, the outer side, not the inner side. It's the outer side. So when we follow the 40 up, we get to our graph right here. Turn 90 degrees and follow it over. It's at 140, and we want this top side here. We want the more than. So the more than from 140 up, 200 minus 140 is 60. So 60 students out of the 200 took more than 40 minutes to complete the problem. Part B, Roberto records the value of each of the coins he has at home. The table shows the results. So here's the value of the coins, and then there are how many coins. Frequency is how many of those coins that he has. So he has 3 1-cent piece, 1 2-cent piece, 3 5-cent pieces, and so on. Find the range of the values. Okay, so we're talking about the values. Find the range. So the highest coin is 50 cents minus 1 cent is 49 cents. That's the range. The mode is most. Well, the most coins that he has is the 20-cent piece, and then the median. Well, if you add these up, 2 plus 4 is 6, plus 2 is 8, 9, 10, 11, 12, 13, 14, 15. There's a total of 15 coins. So that means the middle would be the 8th coin. There's an exact middle, the 8th one. So if we start over here, here's 3, 4, 5, 6, 7, means the 8th one is right in here. So it's the 10-cent piece is the median. Work out the total value of Roberto's coins. So he has 3 1-cent piece. You just multiply all these. 3 times 1, 1 times 2, 3 times 5, 2 times 10, 4 times 20, and 2 times 50. And you add those up and you get 220 cents total. And then work out the mean. Well, there's a total of 220 cents divided by 15 coins. So the average value of a coin is 14.666 or 14.7 cents to 3 significant figures. The histogram, part C, now shows information about the masses of 100 boxes. So here's our histogram with 100 boxes, and it says calculate an estimate of the mean. Well, in order to do the mean, you need to do the frequency times the mid-class value. So here we can see that this first box has a class of 0 to 10. So the mid-class would be 5. 5 is the middle of this one. Then the middle of 10 to 15 is 12.5, and the middle of 15 to 30 is 22.5. 30 minus 15 is 15 divided by, or sorry, 30 plus 15 is 45, divided by 2 is 22.5. That's the middle. So that's our mid-class values. Now we need to find the frequencies. So remember frequency density, which is the height, is frequency divided by class width. So then frequency is frequency density times class width if you multiply the class width to the other side. So we see the frequency density here is 3 times the class width, 10. So 3 times 10 is 30. Over here we have 8 times 5 which is the class width. 8 times 5 is 40. Then over here we have 2 times the class width is 15. 2 times 15 is 30. So our frequency, 30, times the mid-class value, 5, plus 40 times 12.5 plus 30 times 22.5, added up and divided by the total number, and that gives us an estimated mean of 13.25. Comes out as an exact value, so you don't round it, 13.25. Now, number 7, I do make a mistake here, and just goes to show you that even math teachers make mistakes. And it also is a good reminder that you should kind of pay attention to the context. I should have thought it through a little bit. I was probably in a hurry when I worked this out. So notice oranges cost 21 cents each. Alex buys X oranges. So when you buy oranges, you only buy integer values. You don't buy a fraction of an orange or a decimal of an orange. So when I got my answer here is incorrect. 9 is the correct answer. My mistake is right here. So we have Alex buys 0.21 oranges. Bobby buys X plus 2 oranges. They still cost 21 cents each. And the total value was $4.20. So when I distributed here, I get 0.21x plus 0.21x times, then distribute it here to the 2 and you get 0.42. When I rewrote this, I guess maybe because I had 0.21 and 0.21, I wrote 0.21 again, but it was supposed to be 4.20. So I didn't catch this earlier. It should be 4.20 here. Then when you combine your x's, you get 0.42x. When you subtract your 0.42 from the other side, this should be 3.78, not 3.79, should be 3.78. And when you divide 3.78 by 0.42, you get exactly 9 oranges, which makes sense. It should not make sense to you if you get 9.02 oranges. You don't buy a decimal of an orange. So this should have been an indicator to me that I made a mistake somewhere. And I see right away that I didn't carry this number down correctly. I missed it by 1 cent, which is what threw me off a little bit. But the correct answer is 9. So do think about the, context, the real context here of what you're dealing with to make sure your answer makes sense. It can help you find a simple mistake like that. So they could possibly take a point off, even though you get a right answer. 1 point is for the right answer, but if you did wrong work, they could deduct a point for incorrect working. So I'm sorry I didn't catch that before. I do double check my answers. My answer was right, but I do have a mistake in the work there. But you should think about what the math represents. You don't just do math, you think about it as well. Here, part B, the cost of one ruler is R cents. The cost of one protractor is P cents. So the total cost of 5 rulers and 1 protractor is 245 cents. Cost of two rulers and 3 protractors is 215 cents. Write down 2 equations in terms of R and P that solve these equations to find the cost of 1 protractor. So here we have 5 times R plus 1 times P equals 245. And then 2R plus 3P equals 315. So there we have simultaneous equations. I multiplied the top one by 3, brought it down here. So that's 15R plus 3P equals 735. Now subtract them to cause the 3P to cancel out. But I'm going to subtract going up so that it keeps my R positive. 15R minus 2R is 13R. 3P minus 3P cancels out. 735 minus 215 is 520. Divide by 13, you get 40 cents for the ruler, but we want to find the protractor. So plug that back into any one of your previous equations. I picked the 2r plus 3p. 2 times 40 plus 3p equals 215. 80 plus 3p equals 215. And you solve for your p, and you can see that your p is 45 cents. Here we have a kind of a distance rate problem. Carol walks 12 kilometers at a rate of x kilometers per hour, and then a further 6 kilometers at a rate of x minus 1 kilometers per hour. The total time taken is 5 hours. Write an equation in terms of x and show that it simplifies to 5x squared minus 23x plus 12 equals 0. So what we want to do is we want to change everything to time. Here's distance and here's rate. Remember, distance equals rate times time. So if you divide by the rate, that will give you time by itself. So distance divided by rate is time, plus this distance divided by rate is time here, and the two times together add up to 5 hours. So we want to clear our fractions. So we multiply the entire equation by x and x minus 1. When you multiply it over here, the x's cancel, so you get 12 times x minus 1. When you multiply it by here, the x minus 1's cancel, you just get 6x. And then we have to multiply all of these on the right side, so you get 5x times x minus 1. When you distribute that, you get 5x squared minus 5x. So then it's just a matter of moving everything to the right side so that our x squared term is positive. So we have 12x and 6x is 18x, minus the 18x from both sides gives us the negative 23x. And we have the minus 12 right here. So we need to add 12 to the other side, and that gives us the plus 12. And we do end up with the equation that they gave us, 5x squared minus 23x plus 12 equals 0. Now we want to factor that. So the factors of 5 and 1 and 5, the factors of 12 are 1 and 12, 2 and 6 and 3 and 4. And we want to combine them so that we get a 23 by adding, or they're actually both negatives. So here we have 5 and 3 is 15, 1 and 4 is 4, 15 and 4 does not give you 23. But if you do 5 and 4, that's 20. 3 times 1 is 3, 20 and 3 do add up to 23. So we need the 5 with the 4, and we need the 3 with the 1. So that gives us 5x squared. Here's a positive 12, a negative 20, and a minus 3 is minus 23x. So here are the factors to factorize it. We don't need the equal 0, we're just factoring it. Then it asks us to solve it. So you set each one equal to 0. We get x equals 3/5 and x equals 4. Now it asks us to walk down the walking speed during the final 6 kilometers. Notice the final 6 kilometers was x minus 1. So how do we know to use the 4 and not the 3/5? Well, if you use the 3/5, you're going to end up with a negative velocity, which means she's walking backwards or heading in the opposite direction. So that doesn't really make sense. So 4 will be the correct value. 4 minus 1 is walking at 3 kilometers per hour. Now we have a probability question here. The diagram shows 5 cards. Each card has dots in it. Donald, choose a card at random. Write down the possibility that the number of dots on this card is an even number. Well, notice there's 5 cards. This one is odd, has 3 dots. This one has 2 dots, that's even. 4 dots, that's even. 2 dots, that's even. 2 dots, that's even. So 4 out of the 5 cards are even. Write down the probability that the number of dots on this card is a prime number. Remember, prime number is only 1 and itself can divide into it. 4 is not a prime number because 2 can divide into it. 2 is a prime number as well as 3. So again, we have 3, 2, 2, 2. We've got 4 out of the 5 again are prime numbers. Then Donald chooses 2 of the 5 cards at random without replacement. He works out the total number of dots on these 2 cards. Find the probability that the total number of dots is 5. So on his first draw, he can either draw a card that has 3 dots, 2 dots, or 4 dots. So that's going to be our branches, a 3-dot card, a 2-dot card, or a 4-dot card. The 3-dot card is only 1 out of the 5 cards. The 2-dot cards are 3 out of the 5, and the 4-dot is 1 out of the 5. So here's our probability. There's 1 3-dot out of the 5, 3 2-dots out of the 5, and 1 4-dot out of the 5. Notice this adds up to 5 out of 5, or 1. Then we want a total number of 5 dots. So if you started with a 3-dot card, you would then have to go to a 2-dot to get a total of 5. And if you drew the 3-dot first, that means all 3 2-dots are still there, and now there's only 4 cards left because he doesn't put it back. And so 3 out of 4 times 1 out of 5 is 3 out of 20. If you draw a 2-dot card, then that means you need to draw the 3-dot card next to get the 5 dots. And so there's only 1 out of the remaining 4 cards is a 3-dot card. 3/5 times 1/4 is 3/20. If you drew a 4-dot card, you could not get a total of 5 dots. There's no other card available that would add up. There's not a 1-dot card, so this does not work. So you add up these up here, 3/20 and 3/20 is 6/20. If you reduced it to 3/10, that would be okay. I just kept it as 6/20. Find the probability that the total number of dots is an odd number. The total number of dots is an odd number. Notice this is still under the idea that he draws 2 cards without replacement. So again, the first dot or the first card will either be a 3, 2, or 4 with our 1/5, 3/5, and 1/5. That's the same as what we had up here, except now we want to end up with an odd number. So 3 plus 2 is 5, 3 plus 4 is 7. So he could have combined the 3 with either the 2 or the 4, which are all 4 of the 4 remaining cards. So 1/5 times 4/4 is 4/20. If he had drawn the 2-dot card, then to get an odd number, you obviously can't draw another 2 or a 4. You could only draw the 3-dot to make an odd number. So 3/5 times 1/4 is 3/20. If you drew the 4-dot card, then the only one that you could draw to get an odd number is the 3-dot card also. 1/5 times 1/4 is 1/20. You add these up and you get 8/20 or 4/10. A car hire company has X small cars and Y large cars. The company has at least 6 cars in total. The number of large cars is less than or equal to the number of small cars. The largest number of small cars is 8. Write down 3 inequalities in terms of X and or Y to show this information. So here you have, the company has a total of 6 cars. So that means the X plus the Y's, that is the small plus large cars, have at least, so that means greater than or equal to. So 6 would be the smallest number. It could be more than that. So the number of small plus the number of large has to be greater than or equal to 6. The large car's Y, which is Y, has to be less than or equal to the number of small cars. So Y is less than or equal to X. And the largest number of small cars can be 8. So X has to be less than or equal to 8 because 8 has to be the largest that it can possibly be. A small car can carry 4 people and a large car can carry 6 people. One day, the largest number of people to be carried is 60. So this is called a maximization problem. You have the number of small car can people, large car can carry 6 people. And so you're maximizing with 60 people. This is the largest number. So 4 people for every small car, 6 people for every large car. This has to total less than or equal to, because it is the largest number of people to be carried. That means it could be less than 60 people. Then divide that by 2 because they're all divisible by 2. And you can see that your other equation here is 2x plus 3y less than or equal to 30. Now it tells you to, by shading the unwanted regions, show and label the region R. This is called our feasibility region that satisfies all 4 inequalities. So let's look at the x plus y is 6. This is in kind of standard form, or I guess you could call it double intercept form. 6 divided by 1, the coefficient is 6, so it crosses the x-axis at 6, that's right here. 6 divided by 1 is 6, crosses the y-axis at 6. So this line right here is our x plus y is less than or equal to 6. Because it's equal to, make it a solid line. And it's, it says greater than or equal to 6. That would be the right side. We want to shade the unwanted, so we're going to shade the less than. We're going to go opposite the direction of the inequality because it says the unwanted regions. So we shade this over here. Then if we take our y is less than or equal to x, this right here is our y equals x line, crosses the y-axis at 0. It's like y equals mx plus c. The slope is an understood 1, so up 1 over 1. So here is the line y equals x, and it says y less than x, which is what we want. So the unwanted would be the greater than x, which is this direction. So you shade opposite the direction of the inequality. The reason why they put this in bold is because it's sometimes opposite of how curriculum teach it. Some curriculum teach you to shade the wanted region. This wants you to shade the unwanted region. So be careful that you compare that how to your textbook teaches it. Then we have this one here, x less than or equal to 8. So here it crosses the x-axis at 8. That's this line right here. Less than is what we want. Greater than is what we don't want. So we shade this over here. And then this equation right here, 2x plus 3y is less than or equal to 30. Again, 30 divided by 2 is 15. That's this one right here. 30 divided by 3 is 10. That's this one up here. Connect those dots. And we want less, so we don't want the more or greater. So we shade above the line. And when you do all that shading, we have this blank space here in the middle. We label it with the R. This is called our feasibility region. This is the region that satisfies all the criteria necessary. And it says find the number of small cars and the number of large cars needed to carry exactly 60 people. Okay, now if you're looking for an answer out of the feasibility region, it is going to be your integer values that are within the region. And since 60 is a maximum, because it says the largest number to be carried is 60, your maximum is usually going to come from the highest point. So if you check 6 and 6, 6 times 4 is 24, 6 times 6 was 36, because remember 4 and 6, so 4 times 6 is 24, 6 times 6 is 36. 36 and 24 does add up to 60. So notice this was only 1 point. It doesn't want to actually you to go through and calculate all of them. Since 60 was a maximum, it should come from your highest coordinate or your highest vertex, which is at the 6, 6 corner. And so 6 small cars and 6 large cars are used to carry the 60 people. Now it says when the company uses 7 cars, find the largest number of people that can be carried. So now it's giving you the number of cars. Here's your X value and your Y value. Now you're looking for integer values. So you can either have 7X and no Y, 7 small and no large. You can have 6 small and 1 large, 5 small and 2 large, or 4 and 3. You can't go 3 and 4 because it's outside the feasibility region. So these are your 4 possible values that you can have of combinations of 7 cars. And you want to find the largest number of people. So you just, if you had 7 times 2, that would be 7, this is your x that you, 7 times 4 people is 28. If you calculate the 6 and 1, you get 30. If you calculate the 5 and 2, you get 32. And if you calculate the 4 and 3, you get 34. Again, this should make sense because you're looking for the largest number of people. So most likely it's this higher of the coordinates, 4 and 3. And it gives us a total of 34 people. What is the largest number of people you can carry is 34 with 7 cars. Now coming down here, we have sequences. Complete the table for the 5th term and the nth term of each sequence. So in this first one, we can see a pattern of subtract 4 from each one. So the 5th term is going to be -7. To calculate the nth term, we use our arithmetic sequence where we start A1 is the first term 9, n minus 1 times d. D is the difference, which is our -4. Distribute your -4 through, so you get -4n plus 4, and you just combine your 9 and 4, so you get 13 minus 4n is your nth term. Here we see these are all squares, 4 squared, 9 squared, or I mean, 2 squared is 4, 3 squared is 9, 16, 25, so this is 36. Now to put it in terms of n, you want to look at up here. This is n, and this is a 1, but this is a 4. 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared. So we want n plus 1 and then square it. So n is the term that you're on, plus 1, square it gives you your number, n plus 1 squared. So you got to think about it a little bit. Here, these are all just cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So 5 cubed is 125. This is just n cubed, straight from off of your n term. Then this one, 8, 16, 32, 64. You should recognize there's powers of 2 in here. This is 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. So then you go 2 to the 7th. Or if you recognize this as times 2 times 2 times 2, you multiply by 2 and you get your 128. But when you want to get it into the nth term, it is a bit easier if you look at it with respect to it being a power of 2, not just that you multiply by 2 to each one, but you actually look at it as a 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. That way you see that your n is 1, and so you need to add 2 to get your exponent. Here your n is 2, again you need to add 2 to get your exponent. Your n is 3, you need to add 2. So 2 raised to the n plus 1 for your exponent. That one's a little bit trickier to figure out. Now we have this Fibonacci sequence where you add the previous 2 numbers to get the following number. So notice 5 plus 8 is 13. Use this rule to complete each of the following Fibonacci sequence. The first one is easy. 2 plus 4 is 6. 4 plus 6 is 10, 6 plus 10 is 16. The next 2 are a little bit more difficult. You're going to have to try to figure out the pattern. Notice you start here at 1. So, just try numbers. If you start with 1 and go with 1, it's not going to work. Start with 1 and go with 2, it doesn't work. But if you start with 1 and go with 3, 3 and 1's 4, 3 and 4 is 7, 4 and 7 is 11. So you kind of have to think it through a little bit. You might have to do a little bit of trial and error there. Also, this one is a little bit even more tricky because you don't have the first term and you have a negative. So you don't know if your first term can be positive or negative or what. So might take a little bit of thinking for you to figure that one out. That one's more of a challenge. Now we come down here. with these fractions. One term of the sequence is P over Q. Find in terms of P and Q the next term of the sequence. So notice the denominator becomes the numerator of the next fraction. So if this is P over Q, then Q becomes the numerator of our next value. And also notice the two numerators together, added together, become the denominator. 1 plus 3 is 4, 3 plus 4 is 7, 4 plus 7 is 11. So if one term is P and Q, and the next one is Q, because the Q goes to the top, then the next denominator would be P plus Q on the bottom. So again, it's a little bit of pattern recognition there. Find the sixth term of the sequence. Well, here's first, second, third, fourth, fifth. So the sixth term is going to start with an 18 on top, 7 plus, or 18 on top, 18 plus 11 is 29 on the bottom. And that takes us to the end of this IGCSE paper 41 winter, or October, November of 2019. Thank you for joining me and hope to see you again next time.